So for this module E3, we're going to look at advanced step-by-step simulations. So we're going to use again the controller walker, but now we're going to use advanced things like breakpoints and reachability checking on the controller. So for example, we have this specification of the grid world that we already had in module L3, and we can synthesize a controller for that. So let's synthesize a static symbolic controller. This was successful. The controller was saved to disk, and now we can explore this using the controller walker as maybe now both players, just to make it a little bit more interesting. So initially the robot is at position 0, then there are a few variables that we might not care about so much, so we can remove them. For us, maybe the move is very interesting. And then we can see that the robot moves around, but what is actually the interesting part for us might be whether it or when is it in these positions P1, P2, P3. So what we could do is we could add breakpoints, and then we can call this breakpoint the value of this breakpoint. That's some expression that you could evaluate within the specification. So let's call this P1. Currently the value would be unknown because we are not in a system. We're not in a state where the variables are already assigned. Now when we are playing the environment, then the value can be evaluated. Right now it's false. So we will go between unknown and false. But let's also add the other positions. So let's add position P2 and position P3. And maybe also another one where we say the robot at 0 has the value, I don't know, maybe 4. And the robot at 1 has the value also 4. So let's say it's in position 4. This would not be one of the given positions. The interesting positions, P1 would be 0, then P2 would be 0 and upper. Our upper limit is right now defined as 5, and then here it would be 5, 0 for P3. So let's see what happens. Right now the strategy is very much guiding us to the different positions. So now now we move to position 1. So this breakpoint, now it's called a breakpoint, but it's also an evaluation. So we evaluate this expression. Now it evaluates the true. So we are indeed at the at a state that satisfies P1 because we have this position that was satisfying the predicate. Now the define. So now we are satisfying P3. And the order is actually a bit tricky because you can see that we had here the predicate that we always have to visit P1 between P2 and P3. So this is why we have some little bit strange way of patrolling between these positions. Now it's again at P1, then we move to P2, then again, before we go to P3, we would have to visit P1 again. That's what this pattern just down there said. Then we can, so we haven't really seen this last one light up because that is not on the way for the robot. The robot does not have to visit this position. So let's see if this position is possible to reach with the given controller. So now this position describes environment variables, and if we click on a specific element, so maybe this one, this expression, then we can check reachability for this breakpoint, and the dialog tells us that it is possible to reach this breakpoint state and asks us whether we want to go into reachability mode. If we say yes, we want to go into reachability mode, then we will be guided through the complete states, so environment and system states. And it says on this guided route we have 2 out of 2 remaining, so we can simply either, well, select it here or go to the next state here, and then yeah, let's maybe select it here. We arrived, and now if we inspect this, this is a bit surprising. Why would we suddenly arrive at 4-4? It's not really on the way. And then we see here that the last move was actually stay, and then suddenly we jump to 4-4. So this is very similar to what we discovered in module E1, that stay actually allows the environment to go crazy, because we have not defined any assumption for what happens in stay in this specification. So this is how we can reach positions that are not on the way and that the robot would not actively go towards to. So that's a very interesting thing, maybe to also try reachability for things that we know we can't reach. But of course, if we want to find out whether we can reach maybe this P2, then we could also go and check reachability for that. Yeah, so in 7 steps from the initial state, we can reach that. Yep, there we are, we reached it. So these are also ways that we can investigate how the controller works. So to sum up, we are able to have these breakpoints to kind of watch what's going on, whether specific expressions are satisfied, and we can also do reachability for the breakpoints to see how we can reach specific states. Now the task for this would be synthesize a controller for the specification traffic A1 and check whether a state where we have a car on road A, a car on road B, and green B on whether such a state is reachable for the synthesized controller, and then go through the steps to reach there.